A contingency is an event or a circumstance which is possible but cannot be predicted with certainty. Luckily, you don't need to know the definition of the word contingency, but you do need to know how to use contingency tables, even if the examples involved are about balloons. Now, before we can dive into answering questions, let's take a look at what exactly is a contingency table, how do we set it up, and how do we use it to answer our questions. A contingency table is a useful tool for analyzing probability problems. A two-way contingency table keeps record of the outcomes for 2 events and their complements, making 4 events in total. For example, consider a count of maths and maths lit students who do and do not play sports. Our event A can be considered our subject, which will be written in the columns of our table. This is our math and math lit. Our event B is whether the students do or do not play sports, and these are written in the rows of our contingency table. Our totals column keeps account of the total number of ways that an event can occur. So we have our total number of students who take math, our total number of students who take maths lit, our total number of students who play sports, as well as our total number of students who do not play sports. Now, it's always important that the total number of students who do and do not play sports equals the total number of students who do and do not take maths lit. This indicates our sample size and is given in the bottom right-hand corner of our contingency table. Another way this could be written is event A, the total number of ways A can happen, A complement, the total number of ways A complement can happen, as well as event B, the total number of ways B can happen, and B complement, and the total number of ways B complement can happen. And once again, in the bottom right-hand corner is our sample size S. Now that we understand what a contingency table is and how to lay it out, let's look at an example problem. Suppose a balloon seller is testing out new balloons. He decides to do a probability study for 2 different types of balloons, namely red and blue. He uses a contingency table in order to determine their reliability. He inflates the balloons and places them in a warehouse. There are 50 red and 60 blue balloons. In this specific example, the warehouse represents our sample space, containing our total number of balloons. When he comes back the following week, he notices that 10 blue balloons had popped, while 38 red balloons remained unpopped. For our total number of pop balloons, we can add our red and our blue pop balloons, giving us a total of 22 pop balloons. For our total number of unpopped balloons, we can similarly add our red and blue unpopped balloons, giving us a total of 88 unpopped balloons. How did we arrive at that number? Well, let's see. Step 1 is to complete our contingency table. We begin by adding everything that's given to us within the question. So, we know that there are 50 red balloons and 60 blue balloons. We add this in our red and blue totals columns respectively. We know that 1 week later after he arrives, he sees that 10 blue balloons are popped. And similarly, 38 red balloons are unpopped. We can add this into our contingency table accordingly. Now, how do we determine the total number of red pop balloons? This is our total of 50 red balloons minus our 38 unpopped balloons, giving us a total of 12 popped red balloons. Similarly, we can take our total number of blue balloons and subtract our total number of blue pop balloons in order to determine our total number of blue unpopped balloons. That being said, 60 minus 10 equals 50 total blue unpopped balloons. We can then add our total number of red popped and blue popped balloons in order to determine our total number of pop balloons. This is 12 plus 10 equals 22 pop balloons. Similarly, our total number of unpopped balloons is going to be our 38 unpopped red balloons plus our 50 unpopped blue balloons, giving us a total of 88 unpopped balloons. It is always important to check that the total number of balloons is constant. That being said, our total number of red plus our blue balloons should equal our total number of popped and unpopped balloons, as is consistent throughout all contingency table examples. Now that we've set up our contingency table, it's time to answer the questions. Let's take a look at the first question. What is the probability that a randomly selected balloon is red? Now recall that the probability of an event A is the total number of ways that event A occurs over our total number in our sample space. Thus, the probability that a balloon is red is our total number of red balloons over our total number of balloons. Grabbing this directly from our contingency table, we can see that our total number of red balloons is 50 and our total number of balloons is 110. Thus 50 over 110 gives us a probability of 0.45. Now let's look at question 2. What is the probability that a red balloon would be popped? This is an example of conditional probability, and another way to rephrase this question is, what is the probability that a balloon is popped given that it is red? This equals our total number of red and popped balloons over our total number in our sample space, which in this case is our total number of red balloons. From our contingency table, we can see that the total number where the red and popped balloons intersect is 12, over our total number in our sample space, which is 50 red balloons. Thus, 12 over 50 gives us a probability of 0.24. Question 3. What is the probability that a random balloon would be red and popped? Our probability of a balloon being red and popped is our total number of red and popped balloons over our total number of balloons in our sample space. This is 12 over 110 total balloons, giving us a probability of 0.109. Question 4. What is the probability that a random balloon would be blue and unpopped? Our probability of a blue and unpopped balloon would be our total number of blue and unpopped balloons over our total number of balloons in our sample space. This gives us 50 blue and unpopped balloons over 110 total balloons for a probability of 0.45. Question 5 asks, was the condition of the balloon, whether it's popped or unpopped, independent of its color, red or blue? Recall that for an event A and B to be independent of one another, the probability of A and B must equal the probability of A multiplied by the probability of B. Let's see if that applies to our situation. The probability of obtaining a red balloon is 0.45, as we've discussed before, whilst the probability of obtaining a popped balloon would be our total number of popped balloons, 22, over our sample space of 110 balloons. This gives us a probability of 0.2. Thus, if we multiply our probability of a red balloon by our probability of a popped balloon, we get 0.2 times 0.45 for a total of 0.09. Now recall that our probability of red and popped balloons from our previous slide is 0.109. Thus, we can see that our probability of red and popped balloons is not equal to the probability of our red balloons multiplied by the probability of our popped balloons. Therefore, the type of balloon and the outcome of whether or not it deflated are dependent events. In summary, we've learned that a two-way contingency table is a useful probability tool for comparing two events and their complements for a total of 4 events. The columns within our table represent events A and A complement respectively, whilst the rows in our table represent events B and B complement respectively. The sum of our totals row and column respectively is given in the bottom right-hand corner, and this represents the total number within our sample space. Recall that the probability of an event A occurring is the total number of ways that event A can occur over the total number in our sample space. And recall that for two events A and B to be independent, the probability of A and B should equal the probability of A multiplied by the probability of B. When you write your exams, you might have to use a contingency table. But by practicing your math, you can be sure that that will be something to celebrate, rather than something that will burst your bubble.